derivative of different functions. First of all, a into say fx, constant into the function, and that will be this is the first law, ddx of cosec x minus cosec x cot x ddx of sec x tan x already I have mentioned derivatives, of which first order derivative will be discussed first. Students who are now in class 12 or students who are moving to class 12, already you have learned in class 11 finding derivatives of given functions, also few theorems or few rules related to derivative. Actually, I like to mention the revision of derivative learnt in class 11. I start stepwise from definition of derivative or differential coefficient of a given function. We take the function as fx. According to the definition of derivative of fx, the symbols already you have learned: dy dx, f dash x, y dash or dy dx, or y1 or dy, that is the limit h tends to 0, f of x plus h minus fx divided by h. Actually, we write delta x in place of h initially, but we replace that delta x by h, then the revised form is this one. Then this is derivative of the function fx at any point x. Next thing is derivative of fx at a certain point. Say a. At a certain point, say x equal to a. Definition is dy dx, symbol is this, at x equal to a, or y dash at x equal to a, or if dash a, or y1 at x equal to a. These are the symbols used. Note the students to note These are different symbols, and that will be equal to limit h tends to 0 f of a plus h minus fa divided by h. I think you have noted in both cases derivatives at a certain point or derivative at any point x, both are limits. Therefore, the existence of the derivative at a certain point depends on the limiting value of this, and according to the concept of limits, this limit will exist if left hand limit, right hand limit both exist and finite and both be equal. Therefore, we can make this conclusion: if dash A will exist if limit h tends to 0 minus this is called left hand derivative. Other notation is L fa or f dash L f dash a f dash a minus 0, and limit h tends to 0 plus f of a plus h minus fa by h. This is called right hand derivative. And other notations are f dash a or f dash a plus 0 exist. Exist means values of these are finite and equal. Then few laws. Derivative of different functions. First of all, a into say fx, constant into the function, and that will be this is the first law. Also, we can take this one as first ddx of c 0, c constant. Then this one, second one, then derivative of sum or difference of two functions, ddx of u plus v, that is equal to du dx plus minus dv dx. In case of plus sign, we call sum law, and in case of difference symbol, difference law. Then product law means ddx of u into v, that is equal to u dv dx plus v du dx, product law. Then the last one is ddx of u by v. Remember, u, v all are functions of x, that is equal to v square v du dx minus u dv dx. Actually, in class 11 we had up to this. That is the first part of the first order derivative. Then we found the derivatives of some popular function or some standard functions. Number 3, derivatives of standard functions. First one, ddx of x to the power n, that is equal to n x to the power n minus 1, ddx of log function log x ddx of e to the power x, then derivatives of trigonometric functions. I write those serially. ddx of sin x, cos x, ddx of cosine x minus sin x, ddx of tan x, that is equal to sec square x, ddx of cosec x minus cosec x cot x, ddx of sec x tan x, ddx of cosec sec cot x is equal to minus cosec square x. You found these derivatives using definition. Also, by using these laws, you have found first order derivatives of given, say, expression or given functions. Up to this you had in class 11. Now we will move to class 12.